Alright guys, let's continue with our practice for technical interviews. I was thinking about a way of having randomized questions just so everybody's on the same page. I'm trying to have them randomized. So far I've been picking them just like by just pointing the mouse somewhere and just clicking. I tried this option, but it will usually also pick any type of difficulty, so I don't think this is going to help. Let me know if you have any way to have this randomized so far, but for now I'm just gonna like click somewhere and yeah, let's do it this way for now. So our question or our problem now is 1299, replace elements with greatest element on right side. Okay, what does this mean? What does that mean? Replacing elements with the greatest element on the right side. Okay, given an array R, replace every element in that array with the greatest element among the elements to its right. Okay, replace every element in that array with the greatest element among the elements to its right, and replace the last element with -1. So this is probably going to be something along, well, in my mind it's going to be something along the lines of kind of like shifting, or well, not exactly shifting, but it's going to kind of shift the values or switch the values in every single element. So we're basically going to loop through each element, and yeah, we will need, let's see the example, right? We have an array, so for the first element, let's use some drawing. For the first element, we would have the greatest element to the right would be 18. For the second element is 18, so there is no greatest element to the right, or no, I guess it doesn't matter that the greatest element to the right is smaller than the element itself, right? So the greatest element is the 6, then for the 5 the greatest element again is the 6, for the 4 the greatest element is the 6, for the 1 for the 6 the greatest element is the one that is left, the 1, and for the last element we put -1. I mean, in this case what we are looking for is, first we loop, right? For each element we have to loop. For each element we will be looking to the right, we will be looking at the max for all the elements to the right, so we need to have a function for that. Oops. And well, not a function but functionality, we need to have functionality for that, and we will also just store set element into a new array. And so first loop, second max, third store, fourth would be this last element, which we could call -1. I'm thinking for this one we could also have an array that starts with everything at -1, and we just replace the other one, so we don't really have to care about this last one. I don't know if I'm going to implement it this way. Let's just kind of start brainstorming the single pieces first. For element in array, let's see, out array, it's an empty array at the beginning, so for each element in array we could basically have out array, was it append? Let's quickly Google this, Python append array. Not this, my list, we have a list, let's see, this is our list. We are adding gigs which would basically go to the end. So yeah, appending, not prepending, max out of, well, basically we need to have a way of separating, of looking only elements to the right. Looping is one way to achieve this, but I don't like kind of like the crudeness of looping. I would like a more like a logical way of separating things. How could we achieve that? Looking only the elements to the right. So basically we're here, we're looking everything besides this one, right? Then we are here, we're looking everything besides these two. What we could do is have an array which would always be yeah, so we could actually loop for each element. Let's have for loop in len. So what I'm doing here, I'm trying to loop each time for each element, and for each loop I will be working with a different array. In this case we will have reduced array would be the let's see, how can we reduce this array? Well, we start with the big array. We have our array, which would be the maximum array. For this array, we would have element in array in reduced array, and we want basically what we want. After we start looping, maybe it's good to draw this. Let's have a new one. So we start with an array. Let's say it has 3 elements. What we want to achieve is we loop 3 times. So we do loop 3 times. Not a good way to write in this one. For each loop, let's actually have it as text. Loop 3 times. Come on. Loop 3 times. For each loop, work with reduced array. Get max value from reduced array. Put max value in output array. These are all these are the 3 things that we're going to be doing. I'm going to leave the semicolons out. I hope you understand how the proper Python syntax should give you a hint that this is basically 3 different lines of code. So first things first, we are looping, right? We are looping for each time of the array. Actually, we could be looping 1 time less because we are not looping for the last element. So let's have it like that. for each loop, we are, yeah, that's the problem, right? Let's have this at the very beginning. Our reduced array, we could actually even work with this one. I don't want to though. I just want to have it kind of be visible what we're working with. So we have our reduced array. It is the maximum array. And for our first loop, how do we do this? So for our first loop, we are actually subtracting this element because we don't really need it, and we're looking at the max. So we will have an array that is only like this. We're only looking at the max value from here. So max, and we are storing this max value into the out array. And let's do this. So for an element in the reduced array, and it would start from 1, and I assume that was the way to do this. Let's have a quick, I always kind of forget about the indexing. Reduced array equals 1, 2, 3, print reduced array from 1 until the end. Exactly. So for each element, we will have out array append max. Can we do the max on the whole array? I'm assuming yes, but always good to, because I'm not even sure that we could achieve this without math mode. We could, that's good. Yeah, so we're getting append, we are appending, or in our scheme here we are getting and storing on at the same time the max from this reduced array. And we don't even need we don't even need to loop. I'm sorry. We are only looping once. We are only looping once, but we are getting the max element from the reduced array. And we are also making sure that our newly, because after we are done here, we have to actually jump to the next element, then again subtract one element, work with the reduced, well, we're actually having the reduced array over here, but we are only looking for max values from elements at the index 1 and above. So we still have to have our basically last step update. Let's have it like this. Actually, well, I cannot try it on this one, but still, loop 3 times for each loop. Work with this, work with this, work with that, and update our reduced array. Well, reduce the reduced array. Anyway, I think you get what I mean. So reduced array would be like this. So basically having a smaller reduced array, we're going to the next one, we're still getting the max value, and I think this should be it. Now, before I submit, or not even submit, before I even test the result, I usually do a kind of like a mental dry run. So let's have a look what we are doing here. We have our out array, right? It's an empty array. We're going to fill that with our outputs. We have our reduced array. We could actually substitute that here, like we could actually work with this the whole time. Doesn't matter now. A reduced array would be a copy of the initial array. So now we are looping. We are looping for basically in this case 1, 2, 3, 4, 5 times, and for each of the times, for the first time we get 18, for the second time we would get 6, for the third time we would get 6, for the fourth time we would get 6, for the fifth time we would get 1, and as you can see, I forgot to add the very last one. There are many ways to do this. I will just append it for now. And yeah, so we are looping exactly 5 times here, in this case, from 0 to 4, and we are in, I think it should be a range. Actually there was a better way, but let's have it like this, and I'll quickly Google it afterwards. We have output array, we append it with the max element, we reduce our reduced array 1 element. We could actually, I think there was something like drop or whatever function, but it doesn't really matter in this case. And we are appending at the end our last element. So let's see our example. Our example has exactly the same as instructed. I didn't look at any constraints. Well, firstly, we see that our output is exactly the same, which is good news. Input array, so constraints. The length of the array could be a minimum of 1, and so basically if we have an array that is 1, we're basically not going to loop, but we're still going to append. We could test this one. Let's have an array that has I don't know, some value. Run the code. We're expecting a single array that has a -1 value in it, and that is the case. And the values, they also allow us a bound set of values, so we don't really have to care about overflows and stuff like that, which I have seen the medium difficulty questions, and they all start to introduce such possible issues and fringe cases. So for now we can actually just focus on algorithmics. Sorry about that. And at a later point we will also have to deal with some sort of fringe cases when it comes to overflows and stuff like that. So we've prepared. Okay, what I wanted to see here, I don't know, I would usually also Google how to drop elements without this indexing, weird indexing or slicing operation, but I don't think that's an issue. And also we could, like I said, work with just this array. I don't think it helps. I think it makes more sense for somebody reading your code to see that you're working with a array that is reducing, and it gives them a hint what you're actually doing with this one. So let's submit this, and I think it will be a success. And yeah, it was a success. It is very slow. I'm pretty sure they are there is a very Pythonic way of achieving this, like probably a one-liner, and I could see a one-liner if you were going for example, let's quickly document what I know so far about achieving this. So we could have our out array, and it would basically for element in array, and it would be max out of the element for element in array. And problem with this one is that you're always working with the whole array, and you actually need a way of reducing your array in each iteration, and I'm not sure how to achieve this in Python. That's a quick homework for everybody. Let's see. I will be trying to come up with a better solution quickly at the beginning of the next video, and let's see how you guys also fare with researching for this one. I think it only makes sense to leave some stuff out for personal research, because these type of interviews and these type of situations don't really call for actual learning. They only call for like sporadic solution finding and like thinking about an issue, solving an issue ad hoc. And this is why questions like this should be left after the video for everybody to solve, including myself. So yeah, thank you for watching this one, and I hope you learned something, and see you next time. Bye bye. Alright guys, I was thinking of actually talking about this improved solution in the next video, but since I'm still not done encoding the video anyway, I'll just add it to this. So this is what I did after, like for as an improvement for this algorithm. As you can see, it's basically a two-liner. Still not the best, it's still not perfectly readable, but I think at least you can kind of see some improvement. Maybe it's helpful for you. There are plenty of technical things happening here, so maybe it's interesting to go over what's happening. We are more or less still going through our initial, like the same way we executed our initial algorithm. We are going through each element in our array. We are looking at the maximum element, and we are trying with this added syntax here to only look at the elements from the element to the right from each element. So how do we do this? In the first place, we add a single -1 element at the very end of the array, and then we have to iterate. What I did was I iterate through all the elements except the last one, because there is some things happening here with the indexing that kind of require you to do it in this way. You can try out certain parts yourself and see why this was necessary. What you do here is you use the enumerate function in this case, so you're getting an index for each of those elements except the -1, and you're also getting the element. You don't really need the element, but who cares? So for each of those indices, you can imagine, I don't know, you have your array. So the first index will be 0, and what you want to have here is everything starting from the 0th element until the very last one, but you're also you don't really want to include this one. So the syntax is a bit weird. I googled, you should Google array slicing in Python to kind of figure out how these things works. This is like a technique that, like, this notation is something new to me, like the colon index, but what it essentially gives me is everything starting from here. So from here, everything but this index that I specify. So basically everything running from the last element until the index I specified. So in this case, I should be getting, I think it was these three. Yes, you are getting the -1. So basically what this does is it counts backwards, and this tells you where to stop. So you're getting -1, 3, 2, right? And so on for the next iteration. In our index here, we get 1. So we basically see a 1 here. And we are basically at this element, we only want to see these two, and this gives you exactly these two. And if you notice, if you iterate over the next one, so this one, index 2, you are getting -1. And if you had to, first of all, you are only given a list of 3 elements, so you only have to return three loops, right? So we have to restrict our looping anyway. What I did was basically kind of like this is our mask here that will serve for the last element, and that's why I don't want to loop more than index 2 in this case. In this case, so this tells me that our enumerate function should only give me indices up until all the elements until the except the last one. That's why you are doing a slice of the array for all the elements except this last one. And yeah, with this approach, you're basically getting all the maximum elements in this order packed into a list, and the very last loop, which would be here, would return you the maximum element of what's left, and it would be always the -1, so it would return you the -1. It's kind of like a hacky solution, but at least you can see there are very creative ways to do these things in Python, and in this case it was actually pretty interesting to find out some technical way of achieving this. I don't think it would be perfect to try and do something like this at an interview. It just takes a bit too much time to kind of figure it out. Maybe you knew some of these stuff beforehand, so then you would actually be able to do something like this in an interview. For example, if you knew how to do this weird backwards indexing walk until for example, the backwards indexing walk until a certain element. So yeah, I would call this backward index slicing. Something new I learned, and yeah, I'll probably try and use it at some point at an interview, because now I'm kind of confident in that. But yeah, it's not necessary, but it was very helpful and educational. So I hope you learned something interesting. And yeah, let me know what your solutions are in the comments.